So, Udaya, IntuiCell says that there is an inherent problem with the current AI paradigm, in that it's shackled to backpropagation, it's limited to pre-trained information, and it's incapable of that self-driven, on-the-fly learning of humans and animals. But you also say that you have fixed all this, and that's why we're here today.
Yes, look, there are some amazing demos from traditional ML in low-stake applications. But traditional ML isn't intelligent. It's about feeding millions of data points into a large statistical model and leaving it without any capacity to reason or learn.
And what makes that a problem?
When you bring it to real-world environment, it's going to fail on the training data.
And what you're doing isn't incremental improvements, is it? We're not adding more data or more compute here. Instead, you're taking a fundamentally different approach to anything that's been seen in the current paradigm.
Yeah. Look, it's like from early 50s, AI technology has been inspired on how the brain works without a proper understanding of how the brain actually works.
And this is where IntuiCell has some very different thinking, right?
Yes, we have 30 years of contrarian neuroscience research that gives us novel and groundbreaking insights on the mechanisms by which the brain interacts with the world and learn from such interactions.
And these novel insights, where do they take you?
It will allow us to envision intelligence from ground up. That is how we think of sensors, actuators, neurons, and how the neurons are able to solve their local problems.
And what can you do with that?
Yeah, it unlocks fundamentally new learning paradigm that will be able to learn like we do. It's a real digital nervous system that learns in real world, real time. This has never been done before.
So, this is Luna.
Yes, she's not a demo. She's a vehicle for us to intuitively demonstrate our IntuiCell capabilities in real world environment.
And it's that continuous autonomous learning that makes what we're going to see today so extraordinary.
Exactly. It's not pre-trained in simulation. It's not dependent on data sets. And we don't even fine-tune its control architectures. We keep our IntuiCell network architectures on Luna, and it learns autonomously by exploring.
She looks just like an off-the-shelf lab robot.
Yes, it is. We want to show that IntuiCell architectures can learn on any agent.
So you could take this exact generic network and have it on a drone or a mobile robot or any kind of QP, right?
Exactly. This is not limited to robots. Our networks are so generic, we are able to learn any behavior on any agent, physical or digital.
What is Luna going to demonstrate today?
She's going to perform some movements and learn her own mechanics and learn to stand and balance.
And the leash there, is that supporting her? Or?
It's a safety feature. We want her to fall and learn and recalibrate its networks. Unlike animals, it doesn't have a soft tissue, so we don't want it to break. In mammals, how we understand our body and how we learn to walk and stand are emergent features. We learn this from random limb movements all the way within the womb. Luna here, she's trying to emulate similar behavior. Everything is a new experience in real time, just in front of our eyes.
And you've told her to stand, but you haven't told her how to stand.
Exactly. We design our sensors to propagate the problem that they're designed to perceive. And the robot is trying to handle these problems.
And that's unique.
Yes, exactly. We did not predefine any mathematical model explaining the robot its configuration, or neither we have a global cost function telling precisely what to do. The reality of autonomous machines just got considerably closer. There you go. It learned to stand all by itself.
What have we got here?
We are going to give her a new terrain. It will show how she can generalize for novel scenarios.
And if this was traditional ML, this would be where we would go offline, retrain, and then come back, right?
Yes, but this is a new learning paradigm that enables intrinsic learning, similar to how we learn with real-world interactions, continuous learning, and adaptation.
So are we about to see the next generation in AI here?
No, this is not next generation AI. This is the first generation of genuine intelligence.
Okay, so now the terrain is ice. This is going to be hard for her.
You remember before she learned to stand and balance? Now she's going to use that knowledge to adapt and maintain her height in real time on this more complex terrain.
So you've given us this incredible world first, but what we all want to know, of course, is where does this actually take us?
Yeah, now we've made intelligence a starting point rather than the end goal. It gave a gateway of autonomous systems that can learn in real time in the chaos of reality.
And what about Luna? What can we expect to see from her?
Luna, right now she's in her newborn era where she's able to control her body. Now she's going to learn to take small steps. They're going to be shaky, but they're going to be massive for the evolution of intelligence and this new tech paradigm.
And then she emerges from her newborn era, and what happens then?
Then she's going to enter the child era where we will be able to teach her new skills from instructions, all in real world, real time, just like humans and animals do. You'll want to see it.